information, trying to get a handle on something new.
Oh, absolutely. It happens all the time.
We get it. That's why we're here, really to give you the core insights, without all the overwhelming detail.
Exactly. A shortcut, sort of.
Today, we're diving deep into the world of software testing. We're exploring a methodology called keyword-driven testing.
Right. Keyword-driven testing. Think of it as, well, a smart way to make sure software actually works like it's supposed to.
Okay.
At its heart, it's really about automating tests using simple keywords. And these keywords represent specific actions the software needs to perform.
And what's interesting you mentioned is how it separates the technical stuff, the coding, from the actual test steps themselves.
Precisely. That separation is key.
Okay, so our goal today, our mission as we explore this framework, we'll look at its essential parts, the reasons why people use it, how it's applied, is really to understand how keyword-driven testing, streamlines and simplifies the whole software testing process.
Yeah, let's get into it.
So let's really dig in. What is keyword-driven testing? Maybe in a bit more detail.
Okay, so in essence, it's a testing technique, right? It uses data files, often spreadsheets, to store keywords.
Keywords, right.
And these aren't just random words. They're chosen carefully to relate directly to the software application you're actually testing.
So they mean something specific in that context.
Exactly. Each keyword represents a specific action, something that needs to be performed as part of a test. You might also hear it called table-driven testing.
Oh.
Or sometimes action word-based testing. Those names kind of hint at its structured nature.
Gotcha. So the fundamental idea then is to sort of pinpoint these keywords and then connect them to specific actions or functions within the software. Is that right?
That's it, exactly. You identify the keywords and associate them with actions.
Could you give us some concrete examples? What might these keywords look like and what do they actually do?
Sure. So imagine a keyword like open browser. Pretty straightforward. That would trigger the system to, well, open a web browser. Or maybe click. That would simulate a mouse click on a specific button or link.
Okay.
Then you could have something like type text, which tells the system to enter specific text into, say, a search box or a login field.
Right.
Our source material actually gives some good examples for website testing, like log into Duty99 website.
Okay.
You just use the keyword login, and that single keyword, it's linked to all the steps happening behind the scenes, finding the username field, typing the username, finding the password field, typing that, clicking the button.
So it bundles up a sequence of actions.
Exactly. Simplifies it. Similarly, log out to Duty99 website just uses the keyword logout.
Got it. It really is like creating a simplified language just for testing that application. And the source gave a few more examples too, didn't it? We had login for that Guru99 bank demo site.
Right.
Emails to, I guess, trigger sending an email.
Yeah, likely navigating to the email function and composing sending.
Logouts for exiting the site, obviously. And notifications for checking messages.
Exactly, those high-level actions.
So if you want to build one of these frameworks, what are the crucial building blocks? What components do you absolutely need?
Okay, there are several key parts. First, you'll typically have an Excel sheet or maybe some other kind of data table. This is where you actually store and organize your keywords.
The list of commands, basically.
Yeah, pretty much. Then, really important, you need a function library. Think of this like a toolbox. It's a collection of pre-written code functions that actually do the things your keywords represent.
So if you have the login keyword.
Right, the function library would have the actual code that knows how to find the login button, the username field, and interact with them. So when a test runs, the framework reads a keyword from the sheet.
Okay.
And then it calls up the matching function from this library to execute the action.
Okay, so the keywords are like simple instructions that trigger these more complex pre-built actions. Makes sense. What else is essential?
Well, you'll also have data sheets. These are separate from the keywords. They store the specific data your tests need to use.
Yeah.
Things like usernames, passwords, maybe specific text for an email or search terms, the variable stuff.
Right, the stuff that changes between tests.
Exactly. And then, depending on how you build the framework, you might also use an object repository.
An object repository, what's that?
Think of it like a map or maybe an address book for all the elements in your application. The buttons, the fields, the links, labels, everything.
Okay.
Instead of having to put the technical identifier, like the specific code name or XPath, for a button directly into every single test script that clicks it, you store that identifier once in the object repository. giving it a logical name, like login button.
Ah, I see. So if the button changes.
Exactly. If the developers change the button's underlying code or ID, you only need to update it in one place, the object repository, not in potentially dozens of scripts. Makes maintenance way easier.
That sounds incredibly useful, actually. Cuts down on rework.
It really does. And finally, you have the test scripts themselves. These can be, individual scripts for each test case you want to run, or sometimes people use a single main script, often called a driver script, that reads the keywords and orchestrates the whole execution.
Okay, that paints a pretty clear picture of the moving parts. It definitely sounds like it's about building these layers, abstracting things away to make testing more manageable.
That's a good way to put it. Layers of extraction.
But why go through all this setup work? What's the real payoff? What's the core motivation for using keyword-driven testing in software engineering?
There are some really compelling reasons, actually. For one, common actions, things you do all the time in tests, like logging in, can be handled by that standard function library.
Yeah.
That ensures consistency. Every test logs in the same way.
Right, avoids variation.
Yeah. And because the tests are written at this higher level, using simple keywords, well, they become much easier for non-technical people to read and understand. They're less bogged down in code.
So maybe a business analyst could look at a keyword test and understand what it's supposed to do.
Absolutely. That's a big goal. And this naturally leads to a high degree of reusability. You define login once, you use it in 10, 20, 100 tests.
Define once, use many times.
Exactly. And crucially, it hides all that underlying script complexity. The technical details are tucked away in the function library, which means people defining the tests, maybe manual testers transitioning to automation, or those analysts, they don't necessarily need deep programming knowledge to contribute effectively.
That's huge. Lowers the barrier to entry for automation.
It really does. And the result, your test to be more concise, definitely easier to maintain over time, and more flexible when the application changes.
Yeah, I can see that, especially the maintenance part with the object repository you mentioned.
For sure. On large projects, this approach can really cut down on redundant script writing, frees up testers for, more complex or exploratory testing.
That makes a lot of sense, especially involving people without heavy coding skills. So how does the actual testing process work then? Is it always automated, or can you do this manually?
Well, theoretically, you could probably walk through keywords manually, but honestly, it's almost always used in the context of automated testing. That's where the real power is.
Right.
The main goals when you automate it using keywords are things like reducing the cost of maintaining your tests.
We talked about that.
Avoiding duplicated specifications, writing the same logic over and over, getting much greater reuse out of those function scripts in the library, and generally providing better testing support and making the whole setup more portable, easier to run in different environments. The big picture is really achieving more testing coverage with hopefully less overall effort.
More bang for your buck, testing-wise?
You could say that, yeah.
Our source also mentioned something about creating simple tests early on by recording keywords. How does that fit in?
Ah, right. That's an interesting feature some tools offer. The idea is you can initially perform actions in the application manually.
Like you normally would.
Yeah, and a recording tool watches what you do and automatically generates a sequence of keywords based on those actions.
Oh, cool. Like a macro recorder, but for test keywords.
Kind of, yeah. It gives you a starting point. Then you can go back and refine that recorded script, maybe add data variations, make it more robust.
So instead of waiting for the whole application to be finished, this lets you maybe validate core bits as they're being built, catch flaws earlier.
Exactly. It supports a more agile approach. You can get very early feedback on core functions, which is often when bugs are cheapest and easiest to fix. Saves a lot of pain later on.
Definitely see the value there. And just to be clear, each keyword has to be linked to some kind of actual action, right? It can't just be a label floating out there.
Absolutely essential. Each keyword must be associated with at least one command or a test script, or most commonly a function in that function library we talked about.
The thing that does the work.
Right. When the tests run, there's usually a test library or engine part of the overall automation framework that interprets these keywords one by one. It looks up to the keyword, finds the associated function, and then executes that function to interact with the application.
Okay, got it. So if someone wanted to set this up from scratch, what are the main activities involved? What are the big steps?
Generally, you can bring it down into about 5 major steps. Step 1, identifying your keywords. This involves thinking about both low-level actions.
Like click or type?
Yeah, Exactly. And also high-level keywords that might represent entire business processes, like complete purchase or generate report.
Okay, low and high level. Makes sense.
Step 2 is implementing these keywords as executable functions. This is where the coding happens, building out that function library using a language like, say, Python or Java usually.
Building the engine?
Right. Step 3 is creating your actual test cases. This is where you string together sequences of your defined keywords in your Excel sheet or test file to map out what each test should do.
Designing the tests using the keywords.
Exactly. Step 4 is creating the driver scripts. Remember those. The scripts that actually read the test cases and tell the framework which keywords to execute in what order.
The orchestrator.
Yep. And finally, step 5 is, well, executing the automation scripts, and then, of course, looking at the results to see what passed and failed.
Identify, implement, create tests, create drivers, execute. Got it.
That's the basic flow.
And the source mentioned a couple of tools people often use for this, HP, QTP, and Selenium.
Yes, those are definitely two well-known tools in the test automation space that support or can be used to build keyword-driven frameworks. Selenium, being open source, is particularly popular for this.
Right, Selenium's everywhere. Okay, let's circle back to the advantages. We touched on some, but let's really nail down the key benefits. Why choose this?
Okay, yeah. A really significant benefit, as we hinted, is that it lets functional testers, the folks who deeply understand the application but maybe aren't hardcore programmers, start planning and even developing automated tests much earlier, sometimes even before the application UI is fully stable.
How's that possible if the UI isn't ready?
Because they're working with the keywords, the abstract actions. The underlying functions might still be under development or use placeholders, but the test logic, the sequence of keywords, can be defined.
Ah, I see. You're defining the what before the how is fully built.
Exactly.
Yeah.
And because the tests are just sequences of keywords, they don't require that deep programming knowledge to write. Understanding the keywords is enough.
Big accessibility win.
Huge. Plus, the framework concept itself isn't really tied to one specific programming language or automation tool. You could build a keyword framework using various technologies.
Flexible.
Very. It's
Yeah.
generally compatible with, most standard automation tools you might find out there.
That sounds like it could seriously speed things up, especially early on, giving testers a head start.
It often does. It allows for more parallel activity between development and test automation design.
The source also gave some specific sample test cases, didn't it? Using that Guru 99 demo site again. Could you walk us through those just to see it in action?
Yeah, 3 examples, all for the Guru 99 demo site. First one, TCO1, was log into Guru 99 demo site, find out how many transactions were carried out today.
Okay.
So for that test, you'd likely see a sequence like the login keyword, then maybe a keyword like navigate to transactions, then maybe get transaction count, and perhaps verify count equals expected, something like that.
Combining several keywords.
Right. The second one, TCO2, log into Guru 99 demo site, send an email to one of your customers, and then log out.
Okay, similar start.
Yep. You'd have login, then maybe keywords like navigate to mail, compose email, which would probably pull the recipient message from a data sheet, send email, and finally the logout keyword.
Makes sense. And the last one.
TCO3. Log into Guru 99 demo site and check for any notifications received.
Simpler, maybe?
Probably. Just log in, then maybe a keyword like check notifications, which would look for a notification indicator or message.
So these examples really show how you mix and match those predefined keywords to build up different test scenarios covering various features.
Exactly. It shows the modularity and reusability in practice.
Okay, fantastic. So if we had to boil it all down to wrap things up, what's the absolute core essence of keyword-driven testing?
In a nutshell, I'd say keyword-driven testing is a powerful scripting technique. It uses data files, spreadsheets, usually to hold keywords. Each keyword stands for a specific action related to the software you're testing.
And it's mostly used in automated testing?
Almost exclusively, yeah.
Yeah.
And its key characteristic is that clear separation between the test logic, the keywords, and the actual code, the technical implementation in the function library.
Right. And the biggest advantages we keep coming back to are letting people create tests without needing to be expert coders.
Definitely. Democratizes automation.
And the fact that it plays nicely with lots of different automation tools. It's adaptable.
Exactly right. It makes test automation more accessible, generally easier to maintain in the long run, and more efficient overall.
This has been a really, really insightful deep dive. Thank you. It genuinely makes you think, doesn't it, about this whole principle. breaking down complex things into simple, reusable keywords or actions. You start wondering, could you apply that somewhere else? Beyond just software testing? Could a similar, keyword-driven way of thinking help organize things, maybe even automate stuff in your own work or life in ways you hadn't considered?
That's a really interesting thought, applying the pattern elsewhere.
Yeah, definitely some food for thought there. Well, thanks again for joining us on this deep dive.
CTSS Academy.